Okay, this video is going to walk you through how to count the number of ways you can arrange things or the number of ways you can group things. The number of ways you can arrange things are called permutations, and the number of ways you can group things are called combinations. We'll be reviewing a little bit of what we talked about earlier in our previous counting lesson that we had earlier. So let's look at and review what a permutation is first. We talked about the order being important. In this case here, it's coming from one sample space, and you're going to take these things and put them in some kind of order, or put them in some kind of arrangement where you place them somewhere, or you might just give them names. When we do one of those three things, it's typically going to be what identifies a permutation. So let's look at what we did, kind of like our runners in the race before. Here I have 6 people. They're not going to finish a race. They're going to actually sit in 6 different chairs. If I want these 6 people to sit down in 6 different chairs, you would think to yourself, well, how could I count the number of ways I could arrange these guys so that they're all in different spots? Well, I would have 6 choices for the first chair, then I would have 5 for the second, I would have 4 for the third, and so on, and counting my way down. And then you would think to yourself, I remember a shortcut way of how to multiply that all out really fast in my calculator. I could just go 6 factorial, where 6 factorial represented the total number of people that are in the group, and you're going to lay all of them out in the chairs, or put them all in the chairs, and that would then come out to be 720 ways to do that. Or you could just physically type it in 6 times 5 times 4 times 3 times 2 times 1, and get 720 ways that way as well. Now, let's just hypothetically say there aren't 6 chairs, there's only 2 chairs to put these people in, so these chairs are no longer available to sit in. Well, if I want to get rid of those chairs and say I only have 2 chairs to do it, I could use my decision chart and say, well, I have 6 to choose here and 5 to choose here, and now I only have 30 ways to answer this question. If only 6 people could sit down in these 2 chairs, I would have 30 ways to put 2 at a time in these chairs in the specific order that they're in. 30 ways to do that. Now you might think, well, how could I use my factorial still to get this answer? Well, our goal is to try to eliminate this 4, 3, 2, 1. Well, 4, 3, 2, 1, if you recall, is 4 factorial. So if I divided my total that I had here by 4 factorial, that would eliminate these 4 spots right here, leaving me with the 2 blanks that I need to have in my decision chart to make this total work out. So the way we can think about our calculations way of doing this is just always take the total that you have. If you're not going to put all of them back down again, you would then want to divide out the number of factorial that are not placed. Not placed. So if you're taking notes, this would be a good time to write down what a permutation calculation with factorials would look like. You just take however many total things you have. If there's not all those there, I'm going to wipe these out right here. Then I would take 6 factorial over 4 factorial, and then you just have to figure out then this. There were 4 people that didn't get to sit down, so therefore this total in your calculator will work out to 30 ways. Next, that's not the only way you can do a calculation on your calculator for permutations. Again, the decision chart would just be simple as going 6 times 5, but we can also do this a little differently. We just talked about it here. We said you could take 6 factorial over the number not placed factorial, which was 4, and then we had our answer at 30 also. Another way, and a third way, which is the fastest, and I would say the most efficient way to do these kind of permutation questions, is find out how many total things you have and how many are actually getting placed, and we can use our calculator to do so. So if I want to type it in like this, you press 6 math PRB number 2, which is option for permutations, and then the 2 comes from this 2 that you see here. So let me show you how to do it. 6, then you go math, left arrow, option, or select the PRB option, and then choose option 2, and then you have to then type in the last number here, which is a 2. And that's how you do 6 things that are total to get placed in a 2, and the order is important. 30 ways, as you can see here. That's how permutations work. That's as simple as that. So you'll have a total of something that you're going to work with, and there are only going to be a certain number of places that you can put them, and if the order is important, or if you're going to give them names, like a secretary and president and treasurer and so on, giving them names, then we make our size of group that we're going to be putting them into, and the order or the names are important. Then we can figure out our total ways of doing that with the calculator. Next, let's look at combinations. What is a combination? Well, a combination is simply just a group, and it comes from one sample space the same way a permutation does. But it's just a group. We don't care that there's no specific order, there's no placement, and there's no naming of the items. That's as simple as what a combination is. Let's try an example here. Look at this one right here. Let's say I have these 4 letters, A, B, C, D, and I want to say how many different groups of 2 can you make out of the 4 letters that you see here? Well, it's pretty easy to draw with lines how you could pair up these things. So it's kind of like you have 2 blanks you're going to be pairing up, but in this case here I could pair up 1, 2, 3, 4, 5, and 6. I could write out all those combinations of 2 2 letters, but there are 6 ways you could connect and make a group of 2, like you see here, of those 4 letters. So the answer to this would be 6 ways to do that. Now that's not the only way you could calculate that kind of problem. Let's look at it in a different way. Let's look at how we could use this mathematically then to figure the same kind of situation out without drawing lines. Your decision chart would say, well, I need to figure out how many different letters do you have to choose from to put in the first blank of the pairing that you're going to put together. Well, that'd be 4 different choices. Then you also have to put the next option. If you put one of them down, you only have 3 left to go here. But then it's the number of blanks factorial. Well, how many blanks do I have? Oh, I only have two blanks, so that's 4 times 3. Whoops, 4 times 3 divided by 2 factorial. Now, the reason why I'm taking away the 2 factorial is because when you have AB, for example, and BA, if you didn't have this divided by blanks factorial, you'd be having 12 ways to put 2 letters together of the 4, but this is not a new group. It's the same 2 letters. So we always want to divide out our repeats. Since there are 2 letters in our number of blanks that would repeat them, like AB and BA, we divide by 2 factorial. So if you take 12 divided by 2 times 1, or just 2, you get 6 for the answer in this one right here. So 6 ways to do that one, like we just saw a minute ago. If you want to see it in terms of factorials, you take the total number of items that you're working with. In this case, it was 4 letters, and you take that 4 factorial over the ones that are not placed. Does that sound familiar? That was the same as there were 2 that didn't get placed, and then 2 got placed. This is what the permutation looks like. This is what takes out the repeats. So together, all of this would then create your answer of 6 also. If you take 4 factorial divided by 2 factorial, that also gives you 6 ways. Okay? But the first number is what is not placed. The second number is what gets placed. And then unfortunately, 4 cuts in half like that. But you'll see how the next one worked. And this is the best way to do it with your calculator. If you're going to try to find the number of combinations with your calculator, it's as simple as this. You just type in 4, and then you press Math, select the PRB menu, and then choose the NCR option for combinations, and we have our group size being 2. Then when I press Enter, that's the number of ways you can pair up 2 letters out of 4 to choose from. Now, that was a little bit fast and a little quick, but in terms of different ways you could calculate a combination, these are the 3 different ways you could do that. Stick with the one down here if you're looking for the easiest way to do it, though. Next, let's look at an example here to make it a little bit more concrete so you can actually have an example of one that you might see in your homework. If I have an ice cream shop that offers 31 flavors, and I want to see how many different 3-flavor mixtures I could make. Now, when I say 3-flavor mixtures, we don't care about the order of the flavors. They're getting all mixed together as one group, so we don't really care about the order or the arrangement of these flavors. They're all going in as one group. So if I wanted to do this with a decision chart, I would say, well, I have how many flavors to choose from? I got 31 for the first one. I've got 30 left for the second choice, if I'm going to solve this with a decision chart. And then I divide by the number of blanks that I have, or no, 3 flavors, sorry. And then the third flavor would then have 29 choices. And then if I take that and divide by the number of blanks factorial that I have, which is 3 factorial, this will give you the answer. If I want to do this problem with factorials, and if you want to pause the video right now, you can actually see what this is for the number of ways. The factorials one is going to say, well, how many total factorial do you have here? I have 31 factorial. That's my total that I have in the top. Then I have to say about the ones that are going to not get placed. Well, there are going to be 28 flavors that are not going to get placed. 28 flavors not getting placed. And there then will also then be 3 flavors that get placed. And if I do this calculation on my calculator, I'll get the same answer that I have down here as well. And then last of all, if we take our calculator out, which is going to probably be your easiest way to do this, I would say that I have 31 total flavors to choose from, and I'm going to be picking 3 of those, okay? Again, on your calculator, if you go like this and put it in, 31, math, left arrow, option 3, and then put a 3 here, that tells you that you can have 4,495 ways, 4,495 ways to do that. Hopefully you got the same answer right here as well, 4,495, 4,495. And that's how you do combinations. 3 different ways to do it. This is going to be your easiest one right over here. But last of all, just to quickly summarize what we got and what we just spent some time looking at. Permutations, it's the total placed NPR that you're going to use the math right arrow or math choose the menu option for option 2, and the number that get placed. And in the shortcut for combinations, again, you just take the total that you have that you're going to have in your to work with, and then your group size goes in the next spot here. Choose math PBR, sorry, and then number 3 for the option for combinations, and that's it. Combinations are just groups. Permutations are where the order, the placement, or the arrangement, or the naming of those items is important. Good luck, and hopefully this video helps.